Okay, anyway, I'll start today's class. We'll continue with the pests of sugarcane. In the last class, we started the pests of sugarcane. First, we discussed about the early shoot borer, Kylo infescatalis, which is a borer pest causing dead heart, which attacks the crop during the first 3 months of the crop, reducing the crop stand. So we have to discuss about five or six stem borers, of which four are important. One we have completed in the last class. Three more we will complete it today. Hopefully, we'll move into the subterranean pests also today, so that one more class we can finish off sugarcane. So the next borer pest which we will discuss today is uh, Chylosaccharophagus indicus, that is internode borer. So can you see the slides?
Yes, sir.
Yes. Okay. So internode borer, Chylosaccharophagus indicus, that's another major pest. But the peculiarity is that just like what we have discussed in the case of sorghum, the case of sorghum, we had sorghum shoot fly, which was a seedling pest attacking the crop up to 1 month old. Then afterwards, it attacked by stem borer. Similarly, in the case of sugarcane, in the first 3 months, we will have the infestation of early shoot borer, Kylo infescatalis. From fourth month onwards, up to third month, we have infestation of early shoot borer. From fourth month onwards, we will have the infestation of Chylosaccharophagus indicus, that is internode borer. So that's a pest which attacks the crop from fourth month, and its infestation lasts till harvest. That means from fourth month till harvest, we have the infestation of Chylosaccharophagus indicus, and its infestation is usually seen high in those varieties which have high tillering capacity. So those varieties are highly susceptible. And another thing, as the name indicates, the name says that it is a borer of internode. So similarly, the pest attacks the internode. So by the fourth month only, the internode starts forming. The cane starts elongating. At that time only, it will attack. The pest bores into the stem, sugarcane stalk, at the nodal region, near to the nodal region, and enter into the stem. I will show the pictures. You can clearly see that at that time it bores into the stem near the nodal region, and once it enters the stem, and the pest usually attacks 1 to 3 internodes, not only a single internode. It moves from one internode to another. After feeding on one internode, it comes out, move into the next internode. So likewise, it attacks 2 to 3 internodes, and mainly it feeds on the top five internode. It prefers the top five internode, not the bottom portion. So this is the nature of damage. It bores into the stem near the nodal region. It feeds inside in the internode. It can damage 2 to 3 internodes, and it prefers the top five internode. Another typical feature of its life cycle is that we have to understand clearly, for because it is related to its management also. It's not pupating inside the cane. It comes out of the cane and pupate outside the cane. Once it completes its feeding inside the internode, it comes out and pupates outside the cane stalk. So that is one typical feature in its biology which we utilize for its management. And coming to the symptom, as with any other borer, the typical symptom is dead heart formation. And because of the boring of the larvae inside the cane stalk, that cane easily breaks out, because 2 to 3 internodes will be bored completely, tunneled inside completely by the internode borer, and it easily breaks off. And if you see the inside portion of the cane, the bored portion will be reddish in color. Usually in sugarcane, if you see the sugarcane, if any damage occurs to the cane, the inside portion will turn reddish. So because of the feeding injury, the if, damaged portion turned reddish. And another typical feature with internode borer is that because of the feeding of the larvae inside the cane in the internodal region, there will be constriction of the internode. I will show you a very good picture of that. That means the diameter of the sugarcane decreases. It becomes constricted. ചുരുങ്ങി പോകും. And the length of the internode also decreases. So there will be constriction of the internodal region as well as the shortening of internode. So these are the typical damage symptom of internode borer. So it bores into the cane near the nodal region. It feeds inside the internode region. It can move up to 3 internodes and prefers the top 5 internodes. It after its larval stage is complete, it comes out of the cane and pupate outside. The symptom that heart will be the can lead to easy breakage of the cane, and there will be reddening of the cane. And another typical symptom is the constriction of the internodal region and uh, shortening of the affected internodes. So I will show the pictures later. So this is with respect to the damage and symptoms of internode borer. I will show this. You can see it over here, the borehole near the nodal region. This is the nodal region, this is the internodal region. You can see the borehole over here. You can see the borehole very close to the nodal region. See this, you can see the X-ray. And here you can see, just a minute. Here you can see, this is a these two canes, you can see the construction over here. This area, especially this cane, there constriction because of internode borer infestation. And here you can see the internodal length is greatly reduced. Here also you can see internodal length is greatly reduced. So this is the typical symptom of Chylosaccharophagus indicus. This is the picture of the larvae. And coming to its management, as I already told you, pillaring varieties with heavy tillering are more susceptible. So try to go for less tillering varieties. Less tillering varieties can't be completely relied upon because that will reduce the yield. But try to go for less susceptible varieties. And we have a pheromone trap for Chylosaccharophagus indicus. We can use the pheromone traps at the 4th and 5th month after planting because that's the time when internode borer starts attacking. And it is recommended at the rate of 25 traps per hectare. And we can release trichogramma in sugarcane. You can see lot of biological control options are the natural enemies are widely used for sugarcane. So we can release trichogramma chelonis at the rate of 20,000 per week per acre from 4th month to 11th month after planting. One thing you have to keep in why this biocontrol agents are heavily employed for managing sugarcane pests. One reason is that, see, if you, how many of you have seen a sugarcane field actually entered into a fully grown sugarcane field? How many of you? നിങ്ങൾ ആരെങ്കിലും ഒരു fully grown sugarcane ഫീൽഡിന്റെ അകത്തേക്ക് കയറിയിട്ടുണ്ടോ? At least no. നമ്മുടെ മോഹൻലാലിന്റെ ഒരു സിനിമ ഉണ്ടല്ലോ, എന്താണ് കുഴലൂതും പൂന്തന്നല്ലേ എന്നൊക്കെ പറഞ്ഞ ഒരു പാട്ടുള്ള ഒരു സിനിമ. ബ്ലസ്സി ആയിരുന്നു അതിന്റെ സംവിധായകൻ, ഞാൻ എന്റെ പേര് മറന്നു. ഭ്രമരം. Okay, have you seen that in that song there is a sugarcane field shown, and you might have seen it is thickly grown. ഒരു fully grown sugarcane field, we won't be able to move around freely. The entire field will be completely filled with the crop. It is very difficult to move around. And another difficult task is that it is difficult to move around and it is taller than us. And if you want to carry out an insecticide spray, it is extremely difficult because it's difficult to move around the field, and it's very difficult to spray. If it is a crop which is about 1 meter height, it is okay, just like rice, vegetables, cotton, etc. Okay, up to about 1 meter height, we can easily spray by walking through it. But if it is a crop which is about 2 meters high and walking through that crop which is completely grown, it is extremely difficult. So farmers find it extremely difficult to use pesticides. So the biocontrol holds very good potential in sugarcane crop. So Trichogramma chilonis, I will give a few examples how it is being practiced. Don't think that biocontrol is not always working, but in certain crops biocontrol can be effectively used. I told you in the beginning, while introducing the sugarcane crop, I told you about sugarcane mills where the farmers will be brought under a sugarcane mill, and the millers will give all the inputs and all. And in certain sugarcane mills, especially in Tamil Nadu and all, I don't know about UP, Maharashtra and all. In Tamil Nadu, I know especially Shakti sugar mills and all. Shakti sugar mills, you might have heard about the ABT parcel service. At least you might have seen that buses and all. That ABT parcel, the Shakti sugar mills are the owners of the ABT parcel service. The Shakti sugar mills, they have a biocontrol laboratory along with their sugar mill. So those farmers which are coming under Shakti sugar mills can procure the biocontrol agents, Trichogramma. I will tell few of them again, Potasia, Spermiopsis, etc. All those things are reared in the biocontrol laboratory of that sugar mill, and that biocontrol agents farmers will be employing it in the field. So the farmers are benefited because producing this biocontrol agents is not that an easy task. It's not that always commercially profitable venture, but because of the linkage between the sugarcane sugar mill owners and the farmers, this kind of things work. So this practically it is a working solution for pest management in sugarcane. So we can use Trichogramma chilonis at the rate of 20,000 per week per acre from 4 to 11 months after planting. That means continuously for about 7 to 8 months we have to use it every week. So we need to ensure continuous supply of Trichogramma chilonis. And I told you when I told you about the peculiar feature of its biology. That means after completing the feeding of the larva comes out of the cane and pupate outside. So the management, one key management practice is to detrash at 5th and 7th month after planting. I told you in the last class what is detrashing. Removal of the dried outer leaf. So once you detrash it, you are exposing the pupae to predation and parasitization, because pupae will come out and the larvae will come out and pupate. So if we detrash it, the pupae will be exposed to predation. And another thing is, I also told that it attacks about 2 to 3 internodes, not a single internode. So once one internode is fed completely, it comes out and move into the next internode. So during this travel from one internode to the second internode, the larvae will be exposed to predation and parasitization. So this happens only if we go for detrashing. So detrashing is a recommended practice, a cultural practice for the management of sugarcane internode borer. And as I told you, chemicals, it's not that an effective management practice because it is practically difficult, and because it is an internal feeder, it doesn't have much result. So coming to the management, one thing, go for less susceptible varieties. I told you about the less tillering varieties. Then we can go for pheromone traps. As the attack starts at 4th month, we can go for installation of pheromone traps at 4th and 5th month after planting. We can release Trichogramma chilonis at the rate of 20,000 per week per acre from 4th month till 11th month. And go for detrashing at 5th and 7th month because it will expose the pupae and the migrating larvae. And chemical pesticides are not that recommended. So we'll move on to the next borer, the third borer, important borer, that is top borer, Serpophaga, except Talis. Till now, we discussed about borers belonging to the genus Kylo. Now, we will be discussing about a borer which is uh, belonging to the genus Serpophaga, the genus of rice stem borer. So, unlike the pest which is Scyloinfus which is attacking the early stage crop, uh, internode borer which attacks from fourth month, top borer usually attack the later stages of the crop. Though it attacks in the later stages, it causes heavy damage up to 20 to 30% lead loss. The damage is heavy, and another thing is that it leads to early maturity of the crop. That means farmers will be forced to harvest the crop early because there won't be, if the top borer attacks, there won't be further growth of the cane. Further growth of the cane will be arrested. So farmers will be forced to harvest the crop early. So this extremely serious pest. Eggs are laid on the lower surface of the leaf, and just like we had discussed about the Chylopatulus, they had newly hatched larvae bores into the midrib, mines through the midrib of the leaf, and it bores into the spindle leaves, central unopened leaf of sugarcane, the spindle leaf. So it bores into the central unopened leaf and it pupates inside the cane itself. So remember few things. It bores into the midrib because the symptom, we can see a symptom over there. Because of the move or boring of the central shoot, one typical symptom also will be observed that we will discuss in the next slide. So the first we can see, because of the boring of early installed larvae in the midrib, we can see reddish brown discoloration on the tunneled midrib. I will show you a picture of it. See, we can see it over here, a reddish brown discoloration in the midrib. This is because of the tunneling or mining of the first install larvae in the midrib of the leaf. Then another typical feature I will nature of damage I told you is that it bores into the central spindle leaf which is unopened spindle leaf. So that I will show you one. Okay. See, consider this as a unopened leaf. Before unfurling of the leaf, it will be rolled up. The new leaf will be like this. Okay. So the central leaf, before opening up fully, it will be rolled up like this. You might have seen it in many crops. It will be rolled up in banana and all. The new leaf emerging will be rolled up like this. So what will happen is that, consider this as the larvae. Larvae will come and bore into the unopened leaf, spindle leaf. Just a minute, you can see it. Consider the larvae is boring into the unopened spindle leaf. Okay. So once the leaf unfurls, once the leaf slowly unfurls, once it completely comes out, it starts unfurling, and then you can see a row of short holes on the leaf. Can you see it over here? This row of short holes on the leaf. This typical symptom is usually seen in the case of Serpophaga excerptalis infestation. I will show that picture, then you will be able to understand. Can you see it? Number of short holes, a row of short holes in the leaf. 1, 2, 1, 2, this 1, 2, 1, 2. So all the a row of short holes we can see when the leaf unfurls. Then Deepti teacher will take the pest of banana, then there you can understand more where we have a typical pest which causes damage like this. So this is a row of short holes can be leaf when the leaf unfurls because of the damage caused by the larvae when the before opening of the spindle leaf. Then There will be dead heart formation as usual with any other stem borer. But if this dead heart we normally see when the pest attacks just before maturity, during the tillering stage. The central shoot dies and leads to dead heart formation. But one typical feature is that the dead heart caused by top borer cannot be easily pulled off. And usually the larvae attacks the cane when it is fully grown. The larvae enters into the crown, that is the topmost area. It feeds on the apical bud. The central shoot dies. So what will happen if the central shoot dies? If the larvae feeds on the central shoot and the central shoot dies, what will happen? Just like in any other crop, if you remove the terminal bud, what will happen? No further growth. There will be lateral branches. Here, the lateral bud starts sprouting, and lateral sprouting of the lateral buds will occur. And it will lead to the formation of a symptom called as spongy top. Remember this symptom, spongy top. It's a characteristic symptom. So I will repeat it again. The larvae, if the cane is fully grown up, enter into the central shoot, feeds on the terminal bud dies, and the lateral bud sprouts and leads to the formation of a bungee top. That means numerous buds sprouts and together it forms a bungee top kind of symptom. I will show the picture, then you will be able to realize how it occurs. So coming to the symptom of top borer, there will be reddish brown discoloration of the midrib. Then there will be a row of short holes that I told you how it happens. Then there can be dead heart, which cannot be easily pulled out, but if it happens during the tillering stage, but usually the damage occurs in the maturity phase wherein the central shoot will be killed and there will be sprouting of the lateral buds leading to the formation of a symptom called punchy top. This I told you. Here you can see punchy top. You can see 1, 2, 3, 4, 5, 6 buds sprouting because the central shoot died and all the lateral buds started emerging. This is why once this bungee top occurs, the cane will not grow further. The growth of the cane is arrested. So farmer is forced to harvest the crop early. That is one damage caused by top shoot borer. So this is the feeding injury. This is the egg mass. This is egg mass will be usually all the Serpophaga modes will cover the egg mass with the hairs. So that is what that picture shows. And coming to the management part, the top borer infestation is high if the field is flooded, if there is waterlogging is there. So provide drainage to improve to reduce the waterlogging so that the pest population can be reduced. And another thing is that this egg mass will be usually infested with uh, egg parasitoid, natural egg parasitoids. So we can collect the egg mass and keep it in a 60 mesh nylon bag in the field itself. Collect the egg mass and keep the egg mass in a 60 mesh nylon bag, just like a mosquito net. Keep it in that. So what will happen is that all the parasitoids emerges, the parasite from the parasitized egg, the parasitoids emerges, and because of the smaller size of the parasitoid, it can come out of the nylon bag. But even if the egg hatches, there can be unparasitized egg, the larvae cannot come out because larvae are slightly larger in size and it cannot come out of the 60 mesh nylon bags. So this is one practice which is recommended, collection of egg mass and keeping it in 60 mesh nylon bags to facilitate the release of natural enemies but preventing the movement of hatching larvae. Again, we can go for trichogramma. Here, remember the species. This is Serpophaga species. So we have to go for Japonicum, Trichogramma Japonicum at the rate of 2 cc per acre. That means 40,000 eggs per acre. Then there is a natural ichneumoniid parasitoid, Isotima javensis, which is naturally there in the field. It helps in the management of stalk borer. We are not rearing it in biocontrol labs. Then we can go for spraying of the pesticide chlorantraniliprole coragen at the rate of 150 ml in 350 to 400 liters of water per acre. Management: reduce waterlogging, collect egg mass and keep it in 60 mesh nylon bags, release Trichogramma japonicum at the rate of 2 cc per acre. Then there is a natural enemy called Isotima javensis belonging to the family Climonidae. And we can go for a pesticide spray with chlorantraniliprole at the rate of 150 ml in 350 to 400 liters of water per acre. Coming to the next borer pest, this is the fourth most important borer, that is stalk borer Kylo oricelius. Kylo oricelius. This is a pest just after hatching. What it will do is it moves downwards. The eggs are laid on the leaf, and soon after hatching, the larvae move downwards and take shelter in the leaf sheath or in the central wall. Consider this as a leaf. This part is the leaf sheath. So if the eggs are laid over here, the larvae will move down into the leaf sheath and it will remain inside the leaf sheath or into the central wall, the unopened central wall. The young larvae, while moving down, it feeds on the tissues of the upper tissues of the leaf, and once slightly grows up into the second instar, it bores into the cane stalk by making a circular hole. So the first instar, the early instar larvae scrape the leaf surface, and later on the larvae bore into the cane by making circular holes. Then the infestation is severe if we have water shoots. Water shoots, have you heard about water shoots in sugarcane? Water shoots are nothing but unproductive tillers. It doesn't yield any sugar. It is unproductive tillers. So this larvae starts infesting water shoots, and it will help in the carry of over of the pest to ratoon crop. Sugarcane, it's not a sole crop, usually grown as a ratoon crop also. That means after cutting, the farmers will again manure it so that they can go for a second ratoon crop. I think you know what is a ratoon crop. And here, heavily manured, waterlogged, lodged crop and soft varieties are highly susceptible for stalk borer infestation. Waterlogged condition, lodging of the canes, and heavily manured field, as well as soft varieties. If the rind is soft, all of them favors waterlogging, heavy manuring, then lodging of the crop, and soft variety. All this favors Kylo oricelius infestation. So just after hatching, larvae moves into the leaf sheath or into the central world. Early larvae feeds on the leaf surface. Then later on, the larvae bores into the stem. And water shoots are one critical factor which favors the build-up and multiplication of the larvae, especially in ratoon crop. So as I told you, the neonate larvae, the fresh early hatched larvae feeds on the leaf surface. So what it will do is, as it moves down the leaf towards the leaf sheath, it feeds on either sides of the midrib. And we can see a longitudinal orange yellow streak from leaf tip to the base on both sides of the midrib. Larvae moves down the leaf and we can see on either side of the midrib, from leaf tip to base, we can see orange yellow streaks. And because of the feeding of the larvae on the leaf tissue, the leaf sheath decays and dries up. And we can also see dead heart, which is similar to early shoot borer. So again there is a dead heart, but almost similar to early shoot borer. In grown up canes, that means fully grown up canes, we won't see much of early dead heart symptom. There won't be any visual symptom except for the bore holes if the leaf sheath is removed. And because of the boring of the larvae, the inside the stem, there will be reddening and it will emit a rancid odor. What is called as rancid, or what is meant by rancidity? Rancid odor means anyone? ആർക്കും അറിയില്ല what is rancidity? ഓക്സിഡേഷൻ. എന്തിന്റെ ഓക്സിഡേഷൻ ആണോ? ഏത് കേസിലാണ് നമ്മൾ കോമൺ ആയിട്ട് കാണുന്നത്? ഓയിൽ. യെസ്, യെസ്, യെസ്. നമ്മൾ കാറിയ എണ്ണ എന്നൊക്കെ പറയില്ലേ മലയാളത്തില്? So that kind of smell will be there. That rancid odor will be there. So the symptoms: the neonate larvae, while moving down the leaf along the midrib, it will feed on the leaf surface, and we can see orange yellow streaks. It feeds on the leaf sheath, and it leads to decaying and drying of the leaf sheath. Uh, in the early stages, it will lead to formation of dead heart, which is similar to early shoot borer, but later on, it won't produce any visual symptoms. But if you remove the leaf sheath, we can see the bore holes, and it will lead to the reddening of the internode along with the rancid odor. So you can see the bore holes on the stem. That's the only thing which we can see. Unlike internode borer, remember, if there is internode borer, there will be constriction of the internode and there will be reduction in the length of the internode. Here it's not so. We can only see the bore holes. There won't be constriction of the internodal area and the reduction in length of the internodal area. You can see there are a lot of bore holes. Can you see any reduction in the length of the internode? No, there is no constriction of the internode also. That is the difference between internode borer and stalk borer. Coming to the management, again, it moves into the leaf sheath and it remains inside the leaf sheath. So detrashing during September, October is an ideal strategy for management of this pest. Then water shoot helps in its survival. So removal of water shoot at 15 days interval during winter is one cultural practice which helps to reduce the pest population. Then excess nitrogen, waterlogging and lodging of the cane. I told you soft varieties, waterlogging, heavy manuring and lodging of the cane all favors multiplication. So try to avoid all those. And rattoning, especially if the water shoots are infested, avoid rattoning because in heavily infested crop, it will be carried over to the ratoon crop also. Then Trichogramma chilonis, this is Chilo so we can go for Trichogramma chilonis at the rate of 2.5 cc per hectare at 10 to 15 days interval. Then we can release tacinid parasitoid. I told you there are several parasitoids which are used. So for Chilo there is a tacinid. Tacinidae is a diphtheran family. So this is a tacinid. Very rarely tacinid parasitoids which we employed in the case of biocontrol. So we have a tacinid parasitoid Stermiopsis inferens at the rate of 125 gravid females per hectare. We can release tacinid parasitoid Stermiopsis inferens at the rate of 125 gravid females per hectare. And we can release a braconid parasitoid Potatia flavipus. The name is an older name, I forgot to correct it. Actually, the new name is Apanthalus flavipus. Apanthalus flavipus at the rate of, even if you write Potasia, it's fine. Potasia flavipus at the rate of 2000 females per hectare. So we can go for detrashing during September October period. During the winter, remove all the water shoots, avoid rattooning if there is a severe infestation, reduce the fertilization, avoid water logging, avoid lodging of the cane, release Trichogramma chilonis at the rate of 2.5 cc per hectare at 10 to 15, that is 2 weeks interval. We can release tacinid parasitoid Stermiopsis inferens at the rate of 125 gravid females. Gravid females means fertile females, ready to lay eggs. Those females which are mated and ready to lay eggs, gravid females per hectare, or parasitoid, braconid parasitoid, Potasia flavipus at the rate of 2000 females per hectare. When coming to the minor borers, first one is root borer, Polioca depressella. The earlier name was Emelosera depressella. I will quickly go through it because the first four are the major ones, the remaining are minor ones. The eggs are laid on the stem, leaf, or on the ground. It can lay egg on the stem, leaf, or on the ground. And the neonates, though it's called as root borer, it actually doesn't bore into the root. It bores into the stem below the soil. That's the only thing. So that's why it is called as root borer. The neonate larvae bore into the stem below the ground. It may not only attacks the main stem, it attacks the tillers also. Ratoon crops are more susceptible, and its damage is mainly seen in sandy loam soils because it has to bore into the soil and reaches the underground portion of the stem. So if it is a clay soil, it is very thick, it can't bore easily. So sandy loam soils and unirrigated condition favors root borer incidence. So eggs are laid on soil, stem or leaf. It bores into the underground portion of the stem. It attacks tillers also. And sandy loam soils and unirrigated condition favors the multiplication of the pest. The symptoms are yellowing of leaves from leaf apex downwards because it goes out the underground portion. There will be yellowing of because there won't be any translocation of water and nutrients. So there will be yellowing of the leaf from leaf apex downwards, and there will be dead heart, but it cannot be easily pulled out. So that is one thing, dead heart which cannot be easily pulled out. There won't be any offensive odor, and it will lead to reduction in cane length and weight. So this is with respect to root borer. So you can see the underground portion, there will be bored hole and you can see the damage. And because of this, all the translocation will be affected and there will be a lowing of the leaf from leaf tip downward. Coming to the next pest, that is Gurdaspur borer. Earlier name was Asigona stenialis. The new name is Donocostatus stenialis. And here, unlike the other larvae, this is a pest which attacks the cane gregariously. That means so many larvae attack a single cane. So the newly emerged larvae, neonate larvae, enters the cane gregariously through a single hole. That means a larvae makes a hole, and through that hole, numerous larvae enter into a single cane. And it mainly enters through the sheathless internode. That means those internodes which are open, exposed. We have seen Kylo oricelius, which enters the cane through the sheath. Only the sheath internode is attacked. It enters into the leaf sheath and enters into the skin by making borehole. Here it doesn't need any protection of the sheath and all. It enters into the cane through sheathless. Those internode which doesn't have any sheath, and it makes spiral galleries inside the cane. That is one typical feature of Gurdaspur borer. It makes spiral galleries inside the cane, and while remaining inside the cane, it makes minute punctures on the cane from inside. Very small punctures it will make on the cane from inside. And once the larvae reaches the third instar, it moves out. I told you it attacks the cane gregariously in the early stage. All the larvae will be entering into a single internode. So once it grows up, all the larvae cannot survive together in a single internode. So at that time, just like human beings, if the kids grow up, they marry and they move out to newer to their own homes. Similarly, the larvae also migrate to other canes, and because of the attack of Gurdaspur borer, leaves turn yellow and dried up, and because of this gallery it makes in the cane breaks easily and the cane fails to grow, and it will lead to the formation of side shoot. I will take two more minutes to complete the shoot borers. Please bear with me. So Gurdaspur borer, it is attacking the crop gregariously, especially the neonate larvae, who makes a single hole. All the larvae enters into the internode through the single hole. Mainly attacks sheathless internode without any leaf sheath. It makes spiral galleries, and once it reaches the third instar, it migrates from the cane into other canes dispersed, so that it attacks the cane singly, and it leads to yellowing and drying up of the leaf, and the cane fails to grow up and the infested cane breaks up and lead to the formation of side shoot. Coming to the next, Plassey borer, we have discussed about what Plassey is meant in the Indian history and all. Its scientific name is Kylo tumidicostalis, seen in Plassey in West Bengal. Again, it is a gregarious larvae which feeds on the top 3 to 5 internodes. See, in the Gurdaspur borer, it feeds on the internodes which are at the base, unsheathed. Unsheathed ones are normally seen at the middle and lowermost portion of the cake. Here it attacks the top to 3 to 5 internodes. Again, drying up of the crown is one typical symptom. In the Gurdaspur borer also we seen yellowing and drying up of the cane. Again, the affected internode breaks off easily, and the nodes which are close to this affected internode develop set roots. The roots will come out of the nodes which are close to the affected internodes. And heavy soils, that means clay soils and waterlogged conditions, favors the multiplication of this pest. So just remember about Chylota medicostalis. The scientific name is sufficient. This is the one. See, it attacks the internodal area. You can see it drying up of the cane. And the last one is green borer, Rhaphimetopus subglotallus. Again, just remember the scientific name. Again, the eggs are laid in soil, just like root borer. And the larvae is copper green in color. That's why it is called as green borer and leads to the formation of dead heart. Okay. So study well about the first four borers, sugarcane borers. That means early shoot borer, internode borer, stalk borer, and I forgot one, early shoot borer, internode borer, top borer, and stalk borer. The other remaining, you just remember the scientific names. If there are any typical symptoms, you can remember. Just like Gurdaspur borer, which makes spiral galleries. Those things only you can remember. Any doubts? Any clarification? Why we have low attendance?